If you're watching this video, then you probably already know what a ratio is. But just in case, it's the number of times one number contains another number. This can be easily deduced with simple division, like 192 divided by 48, the result of which is 4. But what we'd like to do is express that answer as a relationship between the first and second number, like 192 is 4 times larger than 48. So in other words, there's a 4-to-1 ratio. Well, let's look at how we can tell this story 4 different ways in Excel. We'll begin by using just the simple division process as described a second ago, but we'll use conditional formatting to reformat that answer into that relationship version. Next, we'll look at a raw ratio formula that will allow us to see the relationship as a value related to 1. So every result, regardless of the value, returns this x to 1 relationship. For the third method, we'll use the greatest common denominator function to calculate this answer. This will give us the same answer as the previous two methods, but display the result in a different format. And this is a format you might prefer over the x to 1 ratio format. Finally, we'll use in-formula formatting paired with the substitute function to create the output witnessed in method 3, but do it a little more simply. Be sure to download this file from the link in the video description so you can follow along and also examine the solution file that has all the formulas built and documented. I've got a list of regions with numbers of entries, and these numbers could represent anything. I've got 2 drop-down lists where we can choose 2 of the regions, and then once done, there are 2 lookup functions in these cells that just take the selected region, locate it in the table of data, and return the number of entries. So if we were to go back up here and pick Midwest, we'd see 384. But if we pick Northeast, we see 48. I've named the output of these 2 lookup functions Region 1 and Region 2, and this will just make the formulas look a little bit nicer. So let's start with method number 1, simple division. We'll start with equals, take the result of the Midwest lookup, Region 1, and divide it by the result of the Northeast lookup, Region 2. Hit enter, and we see that the answer is 8, because 48 goes into 384 8 times. But I'd like to see that as a relationship between the first number and the second number. So if we go back to the cell, we'll go up to number formatting, choose more number formats, and we're going to create a custom number format. And in the type field, we're going to type in 2 pound signs, a /, and 2 more pound signs. In the sample, it now shows that there's an 8-to-1 ratio. We'll hit OK. So now instead of just an 8, we see that the number 48 can go into 384 8 times, but the number 48 can only go into 48 1 time. Now let's move on to method number 2. We'll perform the same simple division formula, equals Region 1 divided by Region 2, and that would give us 8. But let's go back to that formula. We'll go back into edit mode, and then we'll concatenate to that in double quotes, :1, close double quotes. I'll hit enter, and now instead of a slash separating the 2 values, I can have a colon separate those 2 values. If I were to go back to these regions and change them, let's say I pick Southeast and Northeast. In the first version, there's a 3-to-2 ratio using that slash as the separator, but in the second version, there's a 1.5-to-1 ratio. Any value that is calculated in this simple division will be related to 1. Moving on to method number 3. For this method, we'll utilize the greatest common denominator function. At its most basic level, the greatest common denominator function, or GCD function, takes a series of numbers and determines the greatest common denominator between those numbers. So if I were to type in equals greatest common denominator, and use Region 1 as my first value and Region 2 as my second value, we can see that 24 is the largest number that is evenly divisible into both 72 and 48. But I'd like to see that as a ratio. So let's go back to the formula. If we were to take this existing formula and take the value in Region 1 and divide it by the greatest common denominator of Region 1 and Region 2, we would get a 3. This is what I want to be on the left side of the ratio. Now going back to the formula, if we just change this from Region 1 to Region 2, then we will get a 2 because this is what I want on the right side of the ratio. So we actually need to create 2 calculations and then concatenate them together into a ratio. So I'll change this back to 1. Now because I don't want to type all this again, I'm going to highlight it and copy it, Control-C. But we could take Region 1 and then concatenate to that a colon and then concatenate to that the calculation we were to perform for Region 2. Hit enter, and we see the 3-to-2 ratio. So this gives us the same answer as method 1, but it utilizes a colon instead of a slash. So where method 2 always related the calculation to 1, method 3 can have the value on both sides of that colon change. So if we were to go up and change this from Southeast to Midwest, we can see that there's an 8-to-1 ratio. But if we change Northeast To southeast, there's a 16 to 3 ratio. So method 2 would show that as a 5.33 to 1. Method 3 shows it as a 16 to 3 ratio. They're both the same answer, it just depends on how you want to tell the story. From a performance point of view, there is a definite downside to this third method, and that is the fact that we are taking region 1 and region 2 and calculating the greatest common denominator twice. Now, there are several ways that you could solve this problem so that GCD only gets calculated one time and then recycled into both sides of that ratio. I want to show you how to solve this using the let function. Now, I'll admit this is not the simplest way to solve this problem. I'm only showing it in case you're familiar with the let function and you like using it. Here's how we could do it. But if you're not familiar with the let function, definitely don't do it this way. So we'll start off with a let function. We'll declare a variable, and I'm going to call it xGCD. The formula that's going to be calculated to store its answer in xGCD is just what we did in method 3, which is the GCD function that takes the result of the region 1 selection and the region 2 selection and calculates the greatest common denominator. So this formula is going to store its answer in this variable. Next, we'll write the actual formula that's going to calculate and display a result on the screen. And this is the formula we used in method 3. But we can greatly shorten this. We do this by taking the result of region 1 and dividing it by the stored result in xGCD. We'll concatenate a colon, and then concatenate to that colon the result of the region 2 selection divided by the value stored in xGCD. Close parentheses, enter, and there we get the same answer. But in this case, the greatest common denominator calculation only had to occur one time. Now, this can be a bit difficult to read in this format, so here's a beautified version of that formula. We take the let function to calculate the GCD for region 1 and region 2, perform that calculation one time, store the result in the xGCD variable, and then we just perform the standard formula, recycling the xGCD variable into both sides of that ratio. Again, there are much easier ways to do this, but I'm just showing it to you this way in case you're familiar with the let function and you favor it. Our final method will use components and strategies that we utilized in earlier methods. So let's start by just saying equals region 1 divided by region 2. Here we get a really long answer that has been completely unformatted. Let's go back to this formula, and we're going to format it formulaically. In other words, we're going to use the text function to apply in-formula formatting. So the value that text is going to be formatting is the output of this simple division. Format for that output will be what we used in the method 1 conditional formatting. So in double quotes, I'll put 2 pounds, a forward slash, and 2 more pound signs. Double quote, close parentheses, and now we get this number/number output. So you can see in method 1, 16/3 is the same output that we get in method 4. But this allowed us to apply the conditional formatting via a formula instead of through a separate tool. Now here's the twist. I don't want to see a slash between those two values, I want to see a colon. So we'll use a substitute function to swap out the slash with a colon. So going back to the formula, we'll go to the beginning, and we'll wrap this entire text division formula inside of a substitute function. So the text we're searching is the previous output, comma, what are we searching for to be replaced? Double quote, forward slash, double quote, comma, what do we want to replace that forward slash with? Double quote, colon, double quote, close parentheses, enter. So we get the same answer that we got in method 1, but formatted in the way that we had it in method 3. All of these answers are the same answer, they're just formatted in different ways depending on how you like to tell your story. If this were me and I had to choose one, I'd probably go with method 4 just because it seems the simplest. But to each his own. So those are 4 different methods for calculating ratios. Well, really 4.5. Let us know in the comments which is your favorite method. And if you've got a method that you like that I didn't cover, put that down in the comments so we can all learn from it. Remember to download this file from the link in the video description, so that way you can go back and look at all the formulas. Thank you for watching, and remember, at BCTI, the learning never stops.